Our brains are hardwired to understand motion through physical contact. We live in an environment defined by friction, where moving forward usually requires pushing against something solid. For a car, forward momentum is a matter of tires gripping the asphalt. The rubber pushes backward against the road, and the road pushes the vehicle forward. In the water, marine vessels use spinning propellers to forcefully displace the liquid around them, using the weight of the water as a brace. Even airplanes rely on the surrounding environment. Their jet engines take in massive amounts of atmosphere and throw it out the back to generate lift and thrust. Across every mode of travel we use on the ground, motion is entirely dependent on having a physical medium to push against. Once you leave the edge of the atmosphere, those rules seem to disappear. The vacuum of space is a void devoid of air, friction, or any physical medium. This creates a massive problem for our intuition. If every vehicle we know needs something to push against, how can a spacecraft move when there is absolutely nothing there? A common myth suggests that rockets lift off by pushing their fire against the ground or the thick air beneath them, using the launch pad as a solid surface to bounce off of. But there's a fatal flaw in that logic. If rockets relied on air to move, they would lose all ability to steer or accelerate the moment they cross the threshold into the vacuum. Solving this paradox requires us to set aside our earthly common sense and look at a fundamental law of physics that works everywhere in the universe. The secret to space travel is contained within a single principle: Newton's third law of motion. This law dictates that for every action, there is an equal and opposite reaction. To see this in action, imagine standing on a skateboard while holding a heavy bowling ball. If you throw that ball behind you, you will immediately roll forward. You aren't pushing against the ground. You move because you threw mass in the opposite direction. A balloon does the same thing. When you release an untied balloon, it doesn't move because it's pushing against the air in the room. It shoots forward because it is throwing air out of its own tail. This proves that forward movement doesn't require a static environment, as long as you can carry your own mass to throw backward. Inside a rocket, this principle is scaled up into a high-precision, self-contained system. Because there's no air in space, the rocket carries everything it needs. It stores fuel alongside an internal oxidizer. When these two mix, they trigger a violent combustion that generates extremely hot, high-pressure gas within the engine. The engine directs billions of these gas molecules out of the nozzle at several kilometers per second. By throwing that exhaust backward, the gas pushes the engine and the rocket forward. The rocket isn't pushing against the vacuum. It is physically pushing against its own exhaust stream to propel itself through the void. While it seems like space is the difficult environment, the atmosphere of Earth is actually a significant physical obstacle for rocket engines. Near the ground, atmospheric back pressure physically pushes inward against the exhaust plume, squeezing it and reducing efficiency. In the vacuum of space, that external pressure vanishes, allowing exhaust gases to escape the nozzle completely unimpeded. This unrestricted expansion generates a higher velocity for the exhaust, which results in more propulsive force. Consequently, rocket engines are more efficient in space than they are on the launch pad. The vacuum of space is not a barrier to travel. It is the ideal, optimized environment for this technology to operate. Once we understand these mechanics, we can view the vacuum as a friction-free highway. Newton's third law, the simple physics of throwing mass backward, is the reason humanity has been able to leave Earth and explore other worlds. If you want to learn more about the science of flight and aerospace engineering, like this video and subscribe for more explorations. Traveling beyond our planet became possible because we looked past our earthly intuition and followed the laws of motion into the void.